You just give this workflow one single image, one flat photo, and it renders out a fully textured, export-ready 3D model, all inside ComfyUI. No Blender scripting, no manual retopology, no UV unwrapping. That's what this Trellis 2 workflow does. And in this video, I'm going to break down exactly how it works, not just which nodes to connect, but what is exactly happening under the hood at every step. Because once you understand that, you'll know exactly which settings to tweak when your model comes out wrong. Let's get into it. So the whole workflow is organized into 4 stages. Stage 1 is the image input. You drop in a photo, it removes the background, and it prepares the image for the AI. Step 2 is the mesh generation. This is where the AI actually builds the 3D shape using diffusion. The same idea behind Stable Diffusion, but in 3D space. Stage 3 is the refinement. It takes in the rough 3D shape that we generated in the previous stage, and it runs it through the same AI model again at a higher resolution to enhance and sharpen the details. Stage 4 is the texturing. Here we wrap the object with 2048 pixel texture map, and we export a GLB file that you can drop straight into Blender, Unity, or a web viewer. 4 stages, 1 image in, 1 3D model out. It's that simple. Now let's go through each and every stage. In stage 1, our job is simple. We load our image and we keep the alpha channel. Alpha channel is nothing but the transparency information of an image. After loading the image, we do image pre-processing. Pre-processing contains 3 steps. First is removing the background. Second is adding some padding around our object so our 3D AI model does not get confused about where the object ends. It essentially gives it some breathing room. Third is we scale everything to 2048 pixels maximum. Bigger inputs don't always mean you get bigger results. However, a bigger input will definitely slow things down. So we cap it at 2048 pixels maximum. Stage 2 is the mesh generation stage. This is the most important stage in this workflow. The node doing the heavy lifting here is the Trellis 2 mesh with voxel advanced generator. I know, it has a big name, but it also has a big job. It runs 3 separate AI passes internally. Pass 1, sparse structure. This is where our Trellis 2 model figures out where the object exists within the 3D space, and it fills up that 3D space with voxels. Voxels you can think of something like 3D pixels. That's it. Pass 2 is the shape. This is where the AI model refines the surface of those voxels into smooth geometry. It's going from a blocky Minecraft style shape to something with actual curves and edges. Pass 3 is the texture slat information. Before we bake in the final texture, the AI model captures the per surface color information called slat. Think of it as the rough color data that the texturing stage will use later. Now let's look at the mesh cleanup chain. And here's the part that most tutorials gloss over, but it's the reason the final model looks so good instead of looking like melted plastic. After the generation, there are 4 cleanup steps. Let's go through each of them. Step 1 is quad remesh. The AI generates geometry with chaotic, unevenly spaced triangles. Not great for texturing. So our quad remeshing node essentially rebuilds the entire surface from scratch with a clean, evenly distributed geometry. Think of it like this. Imagine you draw a rough sketch of a face and then trace it cleanly onto a fresh sheet. Same shape, but way cleaner. It runs at resolution 1024, which controls how fine the grid is. Higher resolution means more detail, more polygons, but it also means slower processing. Step 2 is simplifying the mesh. Now, clean geometry is great, but we have to cap our polygon faces to 2 million here. Our simplify mesh node essentially reduces the polygon count intelligently. It keeps detail where the surface is complex, like around edges and corners, and it removes polygons where the surface is flat and boring. It uses a method called QMesh to do this. We set the target at 2 million faces. You can lower this for lightweight exports, or you can increase this if you want even more detail. Step 3 is filling the holes in the 3D model. The AI only saw one image of our object, the front. So it essentially imagines the back, the bottom, the inside, the side faces, etc. And sometimes it's not that good at guessing it perfectly. So you end up with small gaps in the mesh called holes. Now, the node we're using here patches these holes automatically. A mesh with no holes is called watertight. It's the gold standard for 3D objects. Watertight meshes work correctly in physics engines, 3D printers, and game engines. So that's what we have to aim for, and that's why we're filling the holes. Now, the fourth step in the cleanup process is converting the mesh to a tri-mesh. Here we essentially strip away the voxel data that we no longer need, and we get a pure triangle mesh, the universal 3D format that every tool understands. Here's the output of the mesh generation stage. Our 3D model is taking up shape, but before we send this for texturing, we will do a refinement pass as well to add in even more details. Now let's look at the refiner stage. Think of the mesh generator as a rough sculptor and the refiner as the fine detailer. The mesh refiner node takes a clean tri-mesh from stage 2. It looks at the original image again and runs the AI model a second time at a higher resolution, 1536 in our case. Why run it again? Because the first pass is intentionally low resolution to be fast. Once you have a good base shape, running the refinement pass is much cheaper than doing everything at a higher resolution from the start. And here's the key thing. It sees both the starting image and the existing 3D mesh. It's not starting from scratch. It's correcting and enhancing what's already there. Also, after the refiner, we pass it through the same cleanup chain that we did in the mesh generation stage, which is quad remesh, simplify the mesh, we fill up the holes, and we convert it to a tri-mesh. Same logic, same reason. Every time you run the AI, you need to clean the output. Here's the output after refinement. It may not be visible to your eye, but this refinement process has added more fine details to our 3D model, and now it's ready for texturing. Now comes the final stage, which is texturing and exporting. Now you have a clean, detailed 3D shape, but it's gray, it has no color. Also, it lacks any surface detail. And that's exactly what stage 4 is here to fix. The mesh texturing node does something called UV texture baking. UV mapping is how you take a 2D image and you wrap it around a 3D surface. The same way you would peel an orange and flatten the skin. The letters U and V represent the 2D axis of the textures. Since X, Y, Z are already taken up by the 3D space, so we use U and V here to denote the two axes. This node generates a 2048 by 2048 pixel texture by virtually photographing the mesh from many different angles, and then assembling those photos into a single flat image that wraps perfectly around the shape. Before exporting, we pass our tri-mesh through the smooth normals node. Each polygon on the mesh has something called a normal. Think of it like an arrow that points outward, telling the rendering engine which way the surface is facing. By default, each triangle has its own independent normal. The smooth normals node averages these arrows across neighboring polygons or triangles. The render engine now thinks the surface transitions smoothly even if it's geometrically still made of flat triangles. And this is how you get the organic curved look without adding millions of extra polygons or triangles. Finally, we export our 3D mesh and we save the model as a .glb file. Here's our final output. Looks quite good, especially after you consider that this all came from one single input image. So yeah, image to 3D models are improving at a rapid pace, and I think Trellis 2 by Microsoft is the best 3D model that's open source that's out there. The complete workflow JSON is attached in the description. You can just load it directly into your ComfyUI. Use ComfyUI Manager to load any missing nodes and AI models. Let me know in the comments what object you're going to test this on. If this helped you understand what's actually going inside these workflows, please subscribe. I break down AI tools like this every week. I'll see you in the next one. Bye bye.